Hello and welcome to Wall Street Training's module on Finance 101. My name is Hamilton Lin and I have a background in investment banking and mergers and acquisitions, having worked at Goldman Sachs in investment banking, as well as Bank of America Securities in the mergers and acquisitions group, as well as two other boutique investment banks, all focused on mergers and acquisitions. I am a CFA charter holder as well and the president and founder of Wall Street Training. In the next little segment, we will go through an explanation of the basic financial concepts that one must absolutely master, what we call the Finance 101, Introduction to Finance Topics, that one must absolutely know in order to be able to understand the concepts in the basic financial modeling, valuation, how to analyze and rip apart companies. With that in mind, let's turn to our slides at this point. The concept is what we call the compound annual growth rate, or the CAGR. The CAGR is trying to estimate the average annual growth per year that you will receive. For instance, if you have received a timeline as follows: in time period 0 today, this was worth $10. Next year, this grew from $10, let's say the stock price grew to $11, and then the year after that, it grew to $12.10. What is the compounded annual growth rate here? Well, first of all, you would take your 10%. This was clearly a 10% growth year to year. You would take $11. Once again, that $11 is your future value. You minus your present value. This is a simple percent change formula. And then you divide that by your present value. This equals the percent change of your cash flows. This summarizes, of course, to the future value divided by present value minus PV over PV. And this again summarizes down to future value over present value minus 1. This formula is what we will apply. So we will simply take $11 divided by $10 minus 1. That gets you a 10% rate of return. Doing the same thing for the second time period. $12.10 over $11 minus 1 equals 10%. Once again, just to clarify, 11 minus 10 gets you 1 over that 10. That's this formula. That gets you 10%. If you take 12.1 minus 11.1 over 11.1, that simply gets you equals, 11 minus 11, so that gets you 1.1 over 11, the same 10% again. So what we're saying here is, on average, we grew at 10%. To check this, you take $10 times, actually 1 plus 10% for both, that gets you the 11 and the 12.1. So now, this is the basic concept that we're now going to take to the next level, because what if we didn't grow? What if we didn't grow at exactly 10% a year? Let's take a look at how that works now. So in this particular example here, what we'll see is, well, if I started with $10 stock price and I went to $9.50 in time period 1 and then $12.10 in time period 2, the question posed to you is, what is the average growth rate? The wrong answer would be to do as follows. The wrong answer would be to calculate the intermediate percent change and then take the average. For instance, taking $9.50 divided by 10 minus 1, again, that's your standard percent change formula, that gets you to a change of negative 5%. Then you would grow your $9.50 over the 12 into $12.10. So you take $12.10, the ending future value, divided by your $9.50 minus 1 gets you a change of 27.4%. And if you were to take the average of these two here, if you were to take 27 and 5 and divide, you would now get 11.2%. Normally this would be a plus, but because this is a negative 5%, you're going to simply take the straight average, and that gets you 11.2%. However, when we are calculating compound annual growth rates, that's what we're trying to calculate. You cannot do that. The reason why you cannot do that is simply your $10 grew to $12.10. I want to know, on average, what was the interim time period growth? And that should get you the same answer of 10% from the previous slide. In fact, what we're trying to say is we do not care about the intermediate cash flows. All we care about is the first year and the last year. That will get us our compound annual growth rate. What is the average, quote-unquote, growth over the entire time period? The way you calculate this, again, is to simply take your future value, present value formula. Future value of $12.50, this divided by your present value of 10 minus 1. This whole thing, rather, to the half power. How that works is the following. Recall, our future value, present value formula equals future value over future value equals present value times 1 plus r to the nth power. we are now trying to isolate our letter R. We know our N, 2 years. We know our present value. We know our future value. So let's solve for this. The first way you solve for this is to use algebra and isolate the letter N. So first we would take future value divided by present value. So you divide present value by both sides. That equals 1 plus R to the nth power. Further taking this to the next step and isolating R, you now take 1 divided by N, so future value over present value, to the 1 divided by nth power. That gets you 1 plus R. Now R, therefore, simply equal the future value over the present value, that whole thing to the 1 over n power minus 1. That is how you now isolate the rate that you will gain. And what this means here is I will take my 1210, that's the future value right here, divided by my present value of $10. That came from here and here. That whole thing to the 1 divided by n, or 1/2 power, so taking the square root, minus 1, that gets you your 10%. Again, to crystallize these concepts, what we are saying is we do not really care. We do not care about how you got from 10 to 12, 5, 10. We do not care how you went from time period 0's cash flow to the last time period's cash flow. The fact that is we got to the 1210. That's what we care about. In other words, to reiterate this, the average annual growth rate is not a simple average of the annual growth rates. This is what we mean by CAGR, compound annual growth rate. All we care about is the first cash flow and the last. We do not care about what happened in between. To really quickly check this, if you're a math person, you would take the geometric mean, which means you would take 1 minus 5% times 1 plus 27.4%. You would take that to the 1/2 power minus 1. This is the math right here. You get the exact same 10%. So the compound annual growth rate is simply a quick and easy way to calculate the geometric mean without having to calculate the intermediate time periods, which we needed with the geometric mean. Let's crystallize this now. Let's crystallize this into an actual problem set. So let's go to the next slide. Let's reiterate this formula once again before we do that. Our formula, again, is y over x, our last time period, divided by our first time period, to the 1 over n power minus 1, where n equals the number of years. And here we solve and extrapolate what we just did and how we actually isolate the R, the rate, from our future value, present value formulas. Remember, here's the key. This is tricky. For the CAGR, you will always need one more data point than the number of years. For instance, in order to calculate a 5-year CAGR, 5-year compound annual growth rate, you need 6 time periods. Meaning, if I have 0 and I want to calculate time period 0 in 5 years, what that means, I need 1, 2, 3, 4, 5 years, but I actually need 1, 2, 3, 4, 5, 6 periods worth of cash flows. In fact, I only need the first and the last. But just keep that in mind. When you're calculating what n equals, if I am calculating the number of years n, I need to make sure I have n plus 1 time period to illustrate our beginning value. Then our first year change, second, third, fourth, fifth year change. That means I need 6 time periods altogether. So in this particular cash flow stream, what we are saying is the following. If we had this $15 that we will receive in 5 years, but 10 years, $10 in time period 0, 15 divided by 10 over 1 to the 5th power. You actually have 1, 2, 3, 4, 5, 6 numbers here eventually. 6 numbers, that means that your actual number of years to discount by is only 5. And that means 8.4%. Again, what we're saying is the path of what year 1 through 4 is irrelevant to our calculation. Meaning, if time period 1, this cash flow, this stock price went all the way down, then went back up, then went down, up and down, it does not matter. The point is it ended at this point here. Now let's actually go and look at a better example with actual numbers to further illustrate this. So the example that we have here is as follows. We are given an 11-year historical financials for Walmart. You are now asked to find the CAGR, the compound annual growth rate, for each of sales, COGS, cost of goods sold, operating SG&A, net income, and diluted earnings per share. The first question is, how many years is this? What is N? Remember, we are given 11 years of data. So we always need N plus 1 number of data points to calculate our CAGR. In this case here, we are given, this is again, number of data points, always will equal N plus 1. So we want to calculate the 10-year CAGR. That means if we want 10 years, we actually need 11 data points, 11 years of data. So in other words, if you are now posed with the fact that you're giving 11 historical years, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This actually means n equals 10. So in other words, you can say n will always equal the number of data points, of course, what? Minus 1. And that will be the number of years, the n, that you will use in your discounting there.